So we'll start with unit 3 now in this video, which primarily deals with network layer. I will write in here after in short network layer as N by W network layer like this. It is one of the lengthiest unit among all the 5 units and also very important. So I'll mark it as a star topic. Not only important from your examination perspective, but also from the fact that of practical importance. If you want to take up a job or if you want to pursue your career in networking, then network layer is a very, very important aspect. Okay, particularly if those of you are planning to take up a job in companies like Cisco, which primarily deals with networking domain of jobs, networking cadre of jobs, then essentially the whole subject of network is important, and among that or in that subject of networks, network layer is very important. It is also of practical importance because the whole of internet works based on the principle of the protocol called network layer, which is a popular protocol called IP protocol. So we are going to learn in detail about the IP protocol. Of course, in the presentation, I am going to show you the agenda and all the topics that we are going to learn, all the design issues of network layer. But before that, again, I'm trying to re-emphasize to you the same fact that this topic is primarily very, very important. So pay full attention and try to understand the idea, the philosophies of network layer. So dear student, this is the agenda. Design issues will address various routing algorithms. Is one of the important function of network layer, as we saw earlier also in my first video when I was talking about OSI model. So we discussed in brief about the various functions of network layer. So one of the important functions of network layer is routing. So we are going to study as case studies several routing algorithms, case studies. Okay. Then the second important function of network layer deals with congestion. Congestion is a state of network when too many packets are circulating in the subnet. So that leads to degradation in performance. So therefore congestion control algorithms. Quality of service parameters that affect the performance of subnet, communication subnet, that we will see. QoS, write in short, quality of service parameters. And then the next important issue of network layer, very important issue, deals with internetworking. If I want to connect or interconnect two different networks, there are several issues to be addressed in this interconnectivity at layer 3. That is a function called internetworking. Several types of mechanisms we'll address here. Okay, several protocols also we talk about here like that. And then finally, as a case study, we have implementation of network layer in the internet. Internet means capital I would say, internet, which is our prevalent network. By means of IP protocol, we will talk about the various issues of network layer. Okay, IP protocol. We'll look into IP address formats and then the types of IP addresses, the philosophy of subnetting, supernetting, and then the CIDRs, the classless internet domain routing, network address translation, several other aspects we will see. Okay, so first we'll talk about the environment of network layer. So these are some of the basics. What is the basic concern of network layer? The network layer is basically concerned with getting packets from source all the way to the destination. Source may be in one area, destination may be another area. For example, I am the source here in India, my friend is working in US, so we want to communicate with each other. So therefore this could be the job of network layer to make sure that my data goes from my machine to the other machine in US. And it has to go through several other intermediate routers. That is called routing. So getting to the destination may require making many hops at intermediate routers along the way. I'm going to show you by means of diagram this particular scenario, right? The architecture which is used for ensuring the data transfer from one machine to another machine. So this function of network layer clearly differentiate or contrast with that of data link layer. The data link layer has the modest simple goal of just moving the frame from one end of the wire, not the subnet to the other. So this is wire-to-wire communication. Data link layer, network layer is host-to-host communication. So that is why we say network layer is the lowest layer that deals with end-to-end transmission. So if I want to transmit from one host 1 in India, to host 2, let us say in Germany, my friend is in Germany. So here these two will be connected by means of a communication subnet, which may include routers. I'll show you the diagram with more clarity. So this the insurance of the data that it should be somehow reaching from this end to end is called end-to-end transmission. So if I'm transmitting from one host to another host, that is data link layer issue. So one machine to another machine, one router to another From one end of the wire to the other end, that is data linking. From one end of the machine to the other end of the machine, which has to go through several routers, okay, that is called end-to-end connectivity. So network layer is the lowest level that deals with end-to-end connectivity. So network layer is a complex layer that provides connectivity and path selection between two host systems that may be located on geographically separated network. Just now I told, one may be in India, another may be in Germany. So if you want to remember layer 3 in as few words as possible, think of paths. So these are the important issues of network layer: path selection, routing, and addressing. Addressing means IP level addressing. I already told you, I will talk about it. So at this layer we use logical addressing, not physical addressing. MAC is physical address, IP address is a logical address. So IP address is a 32-bit address, MAC address is. So network layer uses IP addresses generally which is 32 bits in size, is logical address. Okay, because one machine can have different interfaces, and for each interface I can have a different logical address. And the different protocols which are used at this layer are IP, IPX, AppleTalk, ICMP, etc. We are going to talk about all these protocols later on. Okay, and the devices that operate on this layer are routers and layer 3 switches. We have seen this already earlier. Then what are the different issues involved in network layer? These are the various issues that we are going to learn, that we are going to study in this chapter. What is the mechanism of store and forward packet switching? What is store and forward packet switching? I will explain that as my next topic. So what are the services provided to the transport layer? And then the implementation of these services in the form of connection oriented and connection layers. This is also called virtual circuit and datagrams. We'll have a detailed discussion on this. And then that's what we said. And then the most important this thing is this routing and congestion. And then followed by internetworking. So these all is all about this particular unit of network layer. Now coming to the first one, store and forward packet switching. This shows a very clear environment. Imagine this one my host, this is my machine in India, as I said, and this is my friend's machine, maybe perhaps in Germany, as I said. So they are geographically apart, so they need to be connected by means of an ISP, communication subnet, which may include routers, and these are the lines, communication lines, cables, okay, which may be a telephone cable lines, or old ones, or the new ones, fiber optic, or maybe wireless, or something like that. So a host with a packet to send transmits it. So here listen to me. This host, my machine, is connected to the ISP router directly by means of maybe leased line, or maybe fiber optic channel. Whereas the other, my friend's host, is not connected to the ISP router directly, but it has its own LAN, maybe in office, right? This is the office where he is working. So which is so his host is present on the LAN, and on the LAN it has a separate local router. This is the local router of the LAN, and this router is connected to the ISP router. So either the configuration can be like this, or maybe a direct configuration. That's what he's saying in this point. A host with a packet to send transmits it to the nearest router, either on its own LAN or maybe on its own LAN, or a point-to-point link to the ISP. Is a point-to-point link or to the own LAN. So I may transmit through this, or I may transmit directly. The packet is stored there. Suppose if I transmit from here to here, the packet is stored there until it has fully arrived. That is what is the meaning of store. And then the link has finished its processing by verifying. So checksum will be done whether everything that has arrived is correct or incorrect. Then it is forwarded. That is why forwarded to the next router, maybe from here to here or here. That is called routing. Forwarded to the next router along the path until it reaches the destination. Suppose if it comes here, from here again it will decide whether to go here or here. That is what is the meaning of routing. So for that we have several routing algorithms. So this is the meaning of store and forward packet switching, and this is the environment of network layer. I can say this is the environment of network layer. I hope you understand. Okay. Then the second important issue of network layer is services. Every layer n provides services to layer n+1. So therefore network layer provides services to transport layer. So what do transport layer expect from network layer? Network layer provides services to transport layer at the network transport interface that we have seen. Suppose for example, if you say this is the network layer, this is the transport layer, this is what we call interface. We have seen this earlier. This is called interface. So services are provided at this interface. What are the features of these services? The services should be independent of the router technology. Transport layer should not bother which routers is using. Is it using Cisco router or D-Link router or maybe other routers? Should be independent of the router technology. Transport layer does not care whether network layer uses this brand router or that brand router. Should be independent of the router technology. Transport layer should be shielded, prevented from the number, how many, type, and the topology of the router. Which topology you are using? This is called topology, sorry. This is called the topology. Star topology, graph topology, complete graph, or what, bipartite graph, what topology it is using, transport layer does not bother about it. What kind of network it is using, transport layer does not bother. Transport layer simply say that I am going to give you a data, you send it to and make sure that it is arrived at the other end. That's it. And the network addresses made available to the transport layer should use a uniform numbering plan. That is IP addresses, you can say, even across LANs and WANs. It should not be that if I'm having this LAN, I use this type of address, and if I have that LAN, I use another type of address. Should follow a uniform numbering scheme as far as transport layer communication is concerned. So when I say addresses, I have already told you, let me end the presentation and go back there so that I can write down the type of addressing, okay, types of addressing, or the different types of addresses which are used at different layers. At transport layer, we use what is called port numbers. We'll talk about this when we take up a transport layer. We use port numbers. Generally, these port numbers are 16 bits. Network layer uses IP addresses. IP addresses are 32 bits. These are logical addresses, we say. They need not be unique. And then at data link layer, we have seen we use MAC address. MAC address is 48 bits. Okay, this physical address we said. And at physical layer, we generally say bits. So there is no addresses assigned for bits, simply transmission of bits. Okay, so this is the convention, 16 bits. So if you see in terms of frames, so at transport layer we say PDU, protocol data unit. At network layer, the unit of transmission is called packet. At data link layer, it is called frame. And physical layer, it is simply bits. Bits are transmitted. And generally, for example, this is PDU, or maybe I will show it here. It's PDU, protocol data unit, at transport layer. This is transport PDU. So this will have port number. So here let me write port number. So this will be encapsulated in packet. So now this is packet. This packet. So this will have what we call IP address. Right? So IP address will encapsulate the transport PDU. And then finally we have the frame encapsulating everything. This is the frame. The frame will have MAC address. This is the encapsulation. Source MAC address, destination MAC address, source IP address, destination IP address, source port number, destination port number. That's how the addressing goes. So frame encapsulate packet, packet encapsulate PDU, and this whole thing will be broken down into bits and transmitted over physical layer. So this is the paradigm of the different terminologies which are used at different layers. So essentially, this is the issue of basically network layer. These are the brief review with regard to network layer. So again, summarizingly, what I wanted to tell you is the fact that important issues is services, important functions or roles of network layer is services provided to transport layer. This is the first one. So here we are going to talk about in detail later virtual circuits versus datagrams, connection oriented, connectionless. And then the second important issue of network layer that we will discuss in detail is routing algorithms, which is a primary function of network layer. Then dealing with congestion control, and then finally dealing with internetworking. So this is the functionality, internetworking. This is the functionality so far. And to look at this functionality, how is it implemented, we will take up a case study. Which case study? Case study of IP, generally V4, IPv4 protocol. The implementation of network layer in internet. IPv4 protocol. We'll talk about the IP address format. Okay, and then classes of IP addresses, then the concept of subnets, concept of supernets, concepts of network address translation, etc. So this will be the agenda that we are going to have a detailed look at in our coming videos.